All right, good afternoon or morning, boys and girls. By now, you should have step number 3 here finished up for 1.1, solving simple equations. You should have some equations written for these 4 letters here, A through D, and in your own words, you should have talked about what inductive reasoning you came up with for your rules about math, and how can you test a rule. Well, inductive reasoning, if you don't know, is using multiple true solutions or statements to get a specific conclusion. So hopefully you understood and found that it doesn't matter with a triangle when we add angle A, B, or C in any order, it's always going to equal 180 degrees. Okay? Now that step 3 is done, we're going to move you on to step 4, the actual practice. But before we do that, we need to give you a little bit of instruction. So here is that. If you get your interactive notebook out, I want you to set up your notebook, page number 13, as follows. Okay? Write inverse property up at the top and glue in your blue foldable right now. You can pause the video, grab your foldable, and grab some glue. Now that you have your inverse property foldable glued in to page 13, our next task is going to be to take a few notes in understanding the inverse property. This property is critical to knowing like the back of your hand, okay, in order to do solving equations successfully. So here's the first thing we need to do. Inverse, I'm going to write this right at the top. Inverse, I like to say, equals undo. Undo. And I'm going to grab a highlighter and I'm going to highlight this here because it's of extreme importance. Okay? So I want you to think of an inverse as undoing a number. It's like the opposite. Like the opposite. Okay? And you can always make this full screen to see this better, and if you fall behind, feel free to always back up the video. Alright, so here's a couple of things that we need to know, filling in right by my thumb here. The first is, we're going to add a number to its opposite. The answer is 0. This is simply the first way we can get an inverse. So we add a number to its opposite, the answer is 0. Let's check it out. Sliding over. If we add a number to its opposite, we get 0. So 3 plus what is going to give me 0? Well, that's negative 3. Okay? In other words, and a way to think this through is to think that 3 plus what will cancel it out. Okay? So another thing to think of, what cancels it out? In our next problem here, we have negative 7.5 plus blank equals 0. In this situation, I want to think of what undoes, I know I'm not an English teacher, what undoes minus 7.5? This is easy. If I want to get to 0, I'm going to add its opposite to undo it. So negative 7.5 plus 7.5 gives me 0. Perfect. We'll go on to the next problems, but I'm going to slide over a new note. So here is second way. Okay? I can multiply a number by its reciprocal. We've talked about that word before. We worked with fractions. And the answer is 1. So let's take a look. What again is a reciprocal? Well, if I have 5 over 6, my reciprocal is going to be 6 over 5. I switched the numerators and denominators around. Reciprocal. That's what I wrote in there, reciprocal. And here's the explanation for how this works. If we multiply a number by its reciprocal, the answer is 1. Let's check out an example right down here. Okay, we have 5/6. And if we take its reciprocal, so 6 over 5, let's multiply that out. We multiply across, we get 30 over 30. We know that anything over itself equals 1. So when we take the inverse of multiplication, we're actually undoing it with the reciprocal, and we're getting to 1, not 0. So let's do a couple more up here. 2 times blank is going to be 1. Well, I know that 2 is really 2 over 1. That's what I wrote in there. 2 over 1, you can barely see it. So what's the opposite of that? Let's flip the numerator denominator around. I get 1/2. So 2 times 1/2 equals 1. This should make sense, right? 2 over 1 times 1 over 2 equals 2 over 2 equals 1. Works out nice. How about my next one? 3/4 times what equals 1? Well, let's flip the numerator and denominator. 4/3. I can write this out to see if it works. What do you know? I get 12 over 12, and I know that equals 1. Okay, that is your explanation of your inverse property notes. Right now, we're going to take some notes on one-step equations. This is going to go on page 14. But first, I suppose I should give you 2 problems to write underneath page 13's foldable to try on your own. Go ahead, pause the video now, and see if you got these answers correctly. Correct. Okay, welcome back. The answer to undo 3 to get it to 1, we need to take its reciprocal, 3 over 1, and that's going to be 1/3. That'll undo it. For adding, I'm going to take the inverse of 14, or the opposite to get to 0, which is -14. Not a problem. Now I'm going to have you go to page 14. I'm going to have you label it solving one-step equations. I'm going to have you glue in our new green foldables. Okay? At first, it's going to look like this. We're going to fold it in. Okay? And then we're going to cut on the dotted lines where it says cut line right here. You're going to put some glue on the back side of this section and paste it in. I'll give you a moment to do that. Pause it now. All right, now that you have this foldable glued into page 14 of your interactive notebooks, I'm going to start right here in the center and talk about the basics, then do an example of each. So here we go. Our goal with one-step equations is to solve for the missing variable. Okay, so one thing I got to think about and know is I got to get this variable all by itself. It has to happen. We've got to get that all by itself. All right, so how do we isolate the variable? Here's what we do. We use the inverse operation to get rid of the number on the same side of the equation mark. All right, so what does this mean? This means if I have a plus, I am going to change that to a minus. If I have a minus, I'm going to take the inverse of that, which is plus. So that's one section. And if I have times, I'm going to change that to division. And if I have division, I'm going to change that to times. Not too complicated. You guys all know that. Okay? Remember, to get rid of that, it also sometimes means to undo, like I said in our last little foldable. Okay? Remember the golden rule of math. Whatever we do on one side, you have to do to the other. This wouldn't be a bad thing to highlight. So if I add 5 to one side, I gotta do it to the other side. What I do on the left, I do on the right, and so on. Last thing we need to do, it's always a great idea to substitute your answer in place of the variable to check your work. I'll show you what that looks like as well. So here we go. Starting with my one-step addition equation. I have x plus 2 equals 6. This seems very basic. I can tell it should be 4, but let's use our rules. What we do on one side, we do to the other. To undo plus 2, I want to get it to 0. I want to subtract 2 from both sides. If this is new stuff to you, I encourage you to draw this line down the equal sign to separate things. It's a great visual. I know that 6 minus 2 is 4. Plus 2, take 2 away. I know I'm left with x. Those cancel. X is 4. Let's plug it in to see if it works. 4 for x, okay, plus 2 equals 6. Well, 6 equals 6? Yes. Let's try this for subtraction. And once again, if I'm going fast, feel free to back it up and try it again. All right? I flipped over my subtraction one-step equation. I have x minus 9 equals negative 13. I'm going to undo minus 9 by adding 9 to both sides. I'm going to keep things separate by drawing my line. I know that minus 9 plus 9 cancels. I'm left with x. And I have 13 take negatives here and 9 positives. I know I have more negatives, so I'm going to keep my negative sign, and it's going to be negative 4. Okay, let's plug it in and see if it works. Minus 4 for my x right up here, minus 9 equals negative 13. Well, if I'm already negative 4 and I go 9 more farther away, you know what? I get negative 13 equals negative 13. We're all set there. Top section complete. How about multiplication? Here's our problem. Minus 7x equals 42. Remember, when I have a whole number and I want to undo it, I'm going to use its reciprocal. Well, the reciprocal of negative 7, I'm going to do this way down here. I can remember that a whole number is just itself over 1. Its reciprocal is going to be 1 over negative 7. So that means I want to divide by negative 7. So let's divide both sides by negative 7. I'm going to draw my line again. I know that anything divided by itself is 1, or x, and I know that 42 divided by negative 7 gives me negative 6. In other words, x equals 6. If I try it out, it should work out nicely. Negative 7 times 6. So what I did is I plugged in the 6 for x. You know what? That equals 42. Check. Last problem. Great job staying with me. Right here, we have our division example. We have y divided by negative 4, or y 1/4, negative 1/4 over negative 1/4 y equals negative 9. That was a mouthful. Let me start over. Y divided by negative 4 equals negative 9. This is just a division problem. To undo division, I just multiply by its denominator. So let's multiply both sides by negative 4 and see what happens. Because there's really a 1 up here, remember? So my reciprocal is going to be negative 4 over 1. So I'm going to times everything by negative 4 times negative 4. Okay? And that's going to cancel these out, right? And I'm going to be left with y equals 36. Okay? Because negative 4 times 1 is negative 4y, and I have negative 4 on the bottom. That cancels out nicely. Y equals 36. Should I check it quick? Why not? 36 divided by negative 4 equals question mark. Well, that equals 9. I check out. Okay? Great job. The next step for you is going to do your